Hi, I'm Beverly Mackey, and we're going to review subtracting integers. First, let's talk about the opposites of numbers. Basically, to find the opposite of a number, you just have to change the sign. So 5, a positive 5 will become negative 5. Negative 16 will be positive 16, and positive 2 will be negative 2. In math language, we call that the additive inverse, the opposite. Now, let's look at the following. 20 minus 5 equals 15. 20 plus a negative 5 equals, well, we have to recall our addition rules. The signs are different. I have a positive and a negative. So if they're different, D for different, I'm going to find the difference. D for difference, right? So I'm going to find the difference of the absolute values, 20 and 5, that's also 15, and then I will take the sign of the larger absolute value, which is 20, and so it's positive. Now I am going to slow down a little bit. I want you to look at this. These two are the same. They are equal to one another. And in the process of learning to address subtraction of integers, we are going to do just this. We're going to change the subtraction into an addition. We have same answers, but we have a different look. That's all, so to speak, here. And let's analyze what's different. Well, the 20 is the same. We take the subtraction, and it was changed to addition. So that's opposite there. And then we took the 5 and we changed it to the opposite, and it becomes a negative 5. Now I have an addition problem, and I can just apply the addition rules because I already know them. That's why I said earlier, if you understand your addition, subtraction will be so much easier to pick up, to understand as well. We're going to practice doing just that. Here I have the rules for subtracting integers. First, we're going to change the subtraction sign to addition. And then second, we will change or write the opposite of the number that follows the subtraction sign. And then apply your addition rules. But right now I want to just focus on these first two. Okay? And we're just going to practice rewriting them as addition of the opposite. 5. 5 will just stay. We don't touch it. We don't bother it. And then to change subtraction to addition. And the number following that subtraction sign, we change it to the opposite, which becomes negative 8. Now, an analogy that I use to help me remember or to share that with someone else is that think about people. People change their looks, but they're the same person, So that's what's happened here, that we've just changed the look, but it's the same. All right? Negative 4 will remain negative 4. Minus, I change that to plus, and then the 9 will be negative 9. I don't know if I told you that analogy about changing my hair. Recently I cut my hair, and I told the hairstylist I want to keep my length. Because that's the first thing they look at. They want to know how long your hair is. I want to keep my length. But you can do anything else you want. So that's what I say in subtracting integers. Don't touch that first number. Don't touch that first number. Leave that as a negative 2. But you can change everything else. All right, so we're going to change that minus to plus, and the negative 4 becomes 4, opposite. 12 minus a negative 3. 12 stays the same, and then we write the opposite of subtraction, it's addition, and the opposite of negative 3 is 3. Negative 32. A lot of times when you see that negative, you're so tempted to change it, but don't touch it. Plus negative 20. Next one, negative 15. We leave it, negative 15. Change the minus to plus, and the negative 13 will become, very good, 13. Next, we're going to solve them. And I get the feeling that somebody may want to see maybe the first two solved using the color chips or the algebra tiles. So I'm going to do that. And let's remember that I'm going to use the green for positive and red for negative here. And when we're able to match up a positive and a negative, remember I called that the zero pair. That means that we can cancel them. So let's get to work. 5, the positive 5, so I'm going to have 4. That's the wrong color. Okay, positive 5, we'll have 5 positives. 1, 2, 3, 4, 5. Then we're going to have minus a positive 8. 3, 4, 5, 6, 7, 8. That's the original. Now we will have to change it to the addition of the opposite. The 5 remains the same. 1, 2, 3, 4, 5. And we change it to addition. And the positive 8 will become a negative 8. 2, 3, 4, 5, 6, 7, 8. All right, let's match up the positives and the negatives, and we can cancel. They cancel each other out, the zero pair. And we are left with negative 3 equals negative 3. Negative 2 minus negative 4, we have negative 2 minus a negative 4. Okay, we're going to change that into addition. The negative 2 remains negative 2. The minus sign changes to plus. And our negative 4 now becomes positive 4. 1, 2, 3, 4. And then let's find our zero pairs. Negative, positive, we match them up. And what's left is the answer. What are we left with? We are left with 2 positives, and so our answer is 2. Now, it is a little inefficient, I guess, to use chips with larger numbers, so we're going to use the rules that we have above here and apply that to 12 minus negative 3. 12 plus, and negative 3 becomes 3, and the answer is 15. Negative 32 minus 20. The negative 32 remains the same. Change the minus to plus. Change 20 to the inverse, which is negative 20. Good. Now, we have 2 negative signs, and when they are alike, A for alike, we will add, A for add. So we'll add them. 32 and 20 is 52, and we keep the sign negative. Next, negative 15 minus negative 13. Don't touch the first one, it stays negative 15. Change the subtraction to addition. And we will use the inverse of negative 13, which will be positive 13. Here we have addition of different signs. So I'm going to find the difference, which means I'm going to subtract the absolute values. When I subtract 15 from 13, I have 2. And then I use the sign of the larger absolute value, which is negative. This time we will subtract 3 integers. Same rules apply. Do not change the first integer, so it will remain negative 7, but you'll change everything thereafter. So we will change the subtraction to addition. 3, positive 3 will become negative 3. This subtraction sign will also become a plus sign, and then the opposite of 5 is negative 5. And then starting from left to right, we will solve. You have negative 7 plus negative 3. The signs are alike, so we're going to add. Add the absolute values, 7 and 3 is 10, and keep the sign, that common sign. And bring down the next number, plus negative 5. Again, we're adding 2 integers with the same sign or alike signs. Therefore, we will add the absolute values. 15, 10 plus 5, and keep the signs that they share, negative. The answer is negative 15. We have just reviewed subtracting integers.